Okay, so what are your goals? Like, where do you want to go, and how can I help you with that?
Um, like my goal is to, like I mentioned earlier, to essentially upgrade. I have like an easy job right now. Like it's very, very easy, but it's not exactly well paid. And I see like a tech career as an upgrade because you have like I don't have time to pursue a uni degree because I'd like to keep a job and there's no one for me to rely on, like in case I go to uni, and there's like plenty of resources online that I could use and study in my free time. So that's how I think of doing it.
Cool. Okay.
Uh, yeah, I tried
And
to like study Python by myself. I kind of have very limited like knowledge of it, but a I would really, really prefer to start from the beginning, especially if I have like a chance like this to talk to someone who actually knows something. I think it would just be better for me to like start from scratch.
cool. You just now you asked how many hours you should put into this.
Yeah,
That's a tough question to answer. It's going to vary per person. But like, do you have a timeline for when you want to do the career switch?
I don't have a time like whenever I feel like I'm ready, and
Okay. And which
like
like
I don't have like a set goal.
okay,
I
that's
prefer to be comfortable in my knowledge first, then blindly pursue things.
okay. That makes sense. So I can give homework. So how about this? I'll give like some amount of homework after each session. You're not expected to complete all of them, and based on how much you complete, like they'll give us some idea of like what's your bandwidth per week, right? And we can work around that.
Okay.
Okay, I think without further ado, we can get started. So I'm gonna send you a link to a web editor on the web, and I typically start everyone out in this programming language called Pirate. I'm sending you the link now on Zoom chat. Could you open that up? I also ask my students to share the screen with me. You can share that specific tab, that's fine. Just be sure to not like leak anything that could be important or sensitive when you do share your
No,
screen.
no, I switched everything. That might be. How do I share the screen?
So in Zoom, there's a where you would find a Zoom chat on the same row of buttons. There's a button called share. It's a box with an
Yeah,
arrow
yeah,
in it. You
yeah,
just
yeah.
click on that. And you can share a tab or a specific app specifically.
Can you see it?
Yes. Okay, that's perfect. Well, could you zoom in a few times? So that's a Control Plus on Windows. Can need like five more times. Okay, yeah, this is good. Thank you. Okay. So Pirate is a language designed for beginners. It's a very controlled learning environment, which would, I think, be ideal for our situation.
May I interrupt you for a second? Do I
Yep.
need like a pen and a paper to write stuff down or
Nah, I think you're good.
okay.
All right. Though I think it is a good habit to have, but this is also recorded, so you can review this anytime you want.
Oh, okay.
Yeah. Okay. So to begin, as you say, we're going to start from very, very kindergarten levels. I would like you to think of two numbers, and I'd like you to add them with this computer.
Like a 1 plus 2?
Sure. Okay. At the top right, there's a run button. Can we click on that?
Okay.
So what does it say?
The operator must have white space separating it from its operands. Like that?
Let's try it.
Okay.
Nice. So programming is like using a calculator, which is unsurprising because a calculator is a computer, right?
Yeah.
Hmm. let's do something. Can we add a third number in there? So don't delete anything and let's add a third number. Cool, let's run it. Nice. Okay. Can we change one of the plus signs to a minus? No, what's happening here?
The plus and minus operations are at the same grouping level, and parentheses to group the operation make the order of operations clear. So it doesn't know what to do first.
Exactly. So how do we fix this?
Brackets,
Let's try it.
like like this, maybe.
Okay, let's run it. Nice. Yeah, so you put it perfectly. It doesn't know what to do first. There are two operations on the same line, and we need to be specific. So in mathematics in real life, I'm not sure if you heard of BIDMAS or PAMDAS. Uh, so there's a convention f for the order of ma operations in real life mathematics. For example, one should multiply before adding. That does
Yeah.
not exist here. Uh, so in programming, there are many, 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 many operations. In real life, the conventions is like 6 letters long. In programming, it would be at least 20. It would be a lot to memorize. This language is designed for beginners. It doesn't want you to feel a lot of pain, and so it doesn't make you memorize stuff. But this means that you must be specific. You have to add extra parentheses. Okay. Let's Okay, I'm going to show you something different. So far we've explored arithmetic. We can add, subtract all on the same line. Can we delete everything? I'd like you to write two numbers separated by a comma. Now surround everything in parentheses.
Oh, parentheses. It's just English is. I do apologize. English is not my first language. I need to. Okay, is it okay if I check what parentheses means?
Oh, round brackets.
Oh,
Yeah,
sorry.
no, all
It's
good.
just like I come from a Eastern European background, and some of the words are I don't know them yet, so I do apologize for that.
Oh no, all good. Okay, yeah, you're gonna hear me say parentheses a lot. And when I say parentheses here, just think to yourself, oh, round brackets.
Okay.
Okay, and before the first parentheses, could you write num? That's N-U-M? Oh, but before the first parentheses. So before that one. Yeah. Dash or the minus sign. Uh, min, min. Okay, before we run this, what do you think is going to happen?
Does min stand for minimum or
Okay, so let's say this. What would it produce?
I don't know, the biggest minus lowest?
Okay, let's run it and let's see. 7. So why did it give us 7?
Do we need to like define them or
Okay,
I'm not sure.
so numin is a built-in functionality. It's something that the language provides us with, and we can just use it. Um, so why do you think it gave us 7? What is it doing?
Maybe it thinks it's like it's a float number, like 7.8. So we just give it 7. I don't know.
Okay. So I would like you to change around the numbers, and try to reverse engineer what numbin is doing. 5.
It gives the lowest number.
The lowest number. Yes. So what you said just now was correct. The minimum gives the minimum number.
Oh, okay.
Okay, so what's interesting about this is that now we're using words. Just now we plus and minus were symbols, but we're using full words now. If you think about it, that there could exist an infinity of math operations, and there's only so many symbols that we could use. Thus, it's natural that we start using words for operations. Okay, can we um can we add this whole thing to a number? So don't delete anything, and let's add this whole thing to another number.
Like like plus something you mean, or
Yes, but outside. Cool,
and
let's
run
run
it.
it. Ah, so the same way that we can subtract and add on the same line, we can do the minimum operation and addition on the same line. Cool, okay.
So so it
Can
added
we,
5 to 7 practically, yeah.
exactly, yeah. Right, it's back to this idea of order of operations. It's first, oh, we have to add two numbers. What numbers are we adding? Oh, we need to first figure out what's the minimum between 6 and 5. Oh, it's 5. 5 plus 7 is 12. Right?
Yeah.
Okay. Can we move the plus 7? So let's highlight plus 7 and cut it. And can we move that to next to the 5 so it becomes 5 plus 7?
Like here.
Yeah. All right, let's run it. Now we get 6.
No.
All
Yeah,
right.
because 6 is the lowest one. Because this
Yeah.
is 12. Is
Yeah.
that correct?
Exactly. Yeah. So again, back to the idea of order of operations, right? Now the addition happens first before the minimum operation.
But uh does it have to be like this num minus? Can it just be min or not?
So it's a name that's been established by the programming language, and it expects you have to write it exactly, num dash min.
Okay. Because that's why it got me confused when you asked me to explain what it does. I thought like it's like a minus or something.
So the dash is sort of like a space, but we can't actually write space because they all need to be connected together somehow.
Hmm.
Yeah. And num means number. So it just means number min, number minimum.
Yeah.
Yeah. Okay. Um, so far, what we've basically done is we explored arithmetic on a computer, right? We have
Yeah.
numbers and we can do stuff with numbers. There's an order of operations to how we do stuff. And the way the order of operations is determined is via parentheses, these round brackets. Okay. We are going to move forward in time a little bit, and we're going to move from arithmetic to a bit of algebra. So let's delete everything. I would like you to write x equals 1. Okay, let's run it. Okay, so far, whenever we ran something, we always got an answer. But interestingly, we don't get an answer now. All right?
That's
Let, on a new line, can we write x? Just one letter, x. Okay, before we run this, what do you think is going to happen?
nothing.
Okay, let's run it. Let's see.
Oh,
1. Why did we get 1?
because we defined it first, and then we asked the program to show it.
Yeah, right? So just now when we just did x equals 1, all we've done is we're just saying, oh, whenever you see x, you see 1. But because we only wrote x equals 1, nothing was shown to us. But now, on line 3, we rewrote x. So the programming language is going to see, oh, it's an x. What is x? X is 1. So we get to see 1. Okay?
Yeah.
On line 3, can we change it to x plus 1? And before we run it, what do you think is going to happen?
With nothing, and then we need to like write X at line 4 to see stuff, maybe.
Well, let's run it. Let's see.
Okay, I was wrong. Yeah, because we already defined it, I guess.
Okay, and why do we get two?
Well, because we know that we established that x is equals 1, so it's 1 plus 1 equals 2.
Okay, so this idea of, oh, that x becomes 1 and we get 1 plus 1, that this idea is variable substitution, right? Which in algebra, whenever it sees x, it sees 1 instead. It substitutes x for 1. Uh, so in mathematical speak, we say like x is a variable. It's like a placeholder for a value. In this case, x is it holds the number 1. Okay. Can we change on line 2, can we change x equals 1 to x equals 2? And let's see
Can I
what
ask you something?
happens.
Does variable it has to be a number or
Very good question. If it's not a number, what else could it be?
maybe a like I don't know, word? Can it be a word?
Ah, yes, but we'll get to that later actually. But that's a very good question. Yeah. Uh, for now, we're still in number land. We're still working with numbers. We will move on from that eventually. Okay. Could we change x equals 1 to x equals 2? Okay. Before. Oh, yeah, let's just run it. I think you can guess what's going to happen.
Yeah, 3.
Okay. Because x. Yeah, okay, yeah. Um, okay, let's try something different. Can we create a new line after line 2? So that's an empty line between the two lines there. And can we write x equals 3? Now, before we run this, what do you think is going to happen?
Mm, well, I think it's gonna add 3 to 1. That's my that's my guess.
That's a good guess. Okay, let's run it. Let's see.
Okay. So
Hmm.
we need to change its name then, or
Yeah, so I want to first talk about this. It says declaration of a name, right? So whenever we say we declare a variable,
yeah.
uh, so a declaration is sort of like the Declaration of Independence or declaring war. Once you declare something, you have declared it. Like if you declare independence, you can declare it again. Uh, so the same thing here. When we say, oh, x is 2, we have committed x is now 2 and we can't change it. But it's important to note that different programming languages will have different behaviors here. So for example, in Python, this would not give you an error.
Will
Okay.
not?
Yeah, Python will not give you an error here.
Okay.
So we'll get to that in the future. But for now, just remember that you can't use the same name twice. You can only declare something once. Okay. Let's change x equals 3 to y equals 3. And can we change x plus 1 to x plus y? Okay, let's run it. All right, so we can use more than one variables and we can add variables together. It's no different. Adding two variables is no different from adding a variable to a number, right? Because a variable eventually becomes a number. Yeah.
Yeah.
Cool. Okay. Can we change line 3, y equals 3 to y equals x? Okay, before we run it, what do you think is going to happen?
The answer is gonna be 4.
4. Okay, let's see. Let's run it. Yeah.
Yeah.
Because line 3, when it sees y equals x, oh, what's x? X is 2, so y gets 2. Yeah. Line 3, can we change y equals x to y equals x plus 1? Cool, let's run it. And what does it give us? 5.
Well, y is 3 and x is 2, so 3 plus 2 is equals 5.
Cool. Okay, can we swap lines 2 and 3?
2 and 3.
Yeah, lines 2 and 3.
I mean, it's probably gonna give us an error
Okay.
because do I run it?
Why do you say it gives us an error?
because we declare x like after showing it in like y equals like y the y equation doesn't know what x is, so
Mhm.
that might be an issue. I don't.
Okay,
Am I
let's run it.
wrong?
Let's see.
Yeah.
Yeah. So there's a notion of time, right? There's this idea that line two, it hasn't seen line three yet. It doesn't know that X has been defined yet, right?
Yeah.
Back to the idea of order of operations. This idea goes across multiple lines, right? The language, it processes things from top to bottom. It's going to see y equals x plus 1 before it sees x equals 2. The word unbound, whenever we declare a variable like x equals 2, we say we are making a binding. We are binding x to 2. Uh, so when we say x is unbound, we're saying that x doesn't have a value. It's a bit of vocabulary. You don't really need to know that, but if you see that again, that's what it means. Okay. So this is a bit of algebra, mainly the idea of variables and variable substitution. Okay, let's move on to a different idea in algebra. Can we delete everything? Um, we are now going to move on to functions. So before we start writing functions, what is a function?
In math,
Yeah,
um, like a like an arithmetic equation, like
sure.
a square plus bx plus c. It's just I did math ages ago. Like I said, I did it not in English, so I'm a bit struggling to explain what it
Hmm.
is. Like a formula, perhaps something
Okay.
closer to that.
They're all related ideas. Okay, I'll give you an example of a math function. You know, like f of x equals x plus 1.
Yeah.
Okay, we're going to do that here. We're going to do that in this programming language. To write a function, first you need to write fun. So that's fun. Okay, notice how it's bolded. It's a special word. We're telling the programming language we are writing a function now. Okay, let's write space. So after this, we need to write the name of the function. So let's write space and then f. So we are calling our function f. Next, opening parentheses. Next, we need to write the inputs. Let's write x, closing parentheses, colon, a colon. That's the key to
Is
the
it,
right of L. Actually, your keyboard might be different from mine. That's like, yeah, that's it. On a new
how is
line,
it called again?
a colon. That's a colon.
Okay, I do apologize
All good.
for the lack of knowledge.
Uh, all good. You'll know that now. And everyone has to start somewhere, right?
Yeah.
Let's do a new line and let's write x plus 1. New line, end. Okay, let me do some explaining. So what is a function? A function in mathematics takes in input and produces an output. Input to output. Okay?
Yes.
So already a function has at least two things. It needs an input and it needs an output. So on line two, x is the input. This is what the function takes in. So x is sort of like a variable. It's going to be a placeholder for some value. Line three, we call this the body of the function. Because a function needs an output, but how do we get the output? Where does the output come from? Well, we take the input and we do stuff to it. We compute an answer from it, and that becomes the output. Line three, the body is what's responsible for taking the input, doing stuff to it, and producing the output. The body produces the output. Okay? So in this case, it takes whatever x is and adds one to it. So
Sorry, I was writing. Is that Did you say add one?
In this case, yes, the body will add 1 to whatever x
Yeah,
is.
yeah.
Okay. So two things so far. We have the input and we have the body, which produces the output. But there's a third thing. That f is the name of the function. And we'll see why that's important later. A function has a name, an input, and the body which produces the output. One additional thing, there's a bit of vocabulary, but in programming, you'll hear this a lot. We call the input parameters. So we say x is a parameter. So you will hear me say the word parameter. Whenever I say parameter, just hear input. Okay. So let's run it. Okay, nothing happens. Just now when we wrote x equals 1 and we ran it and nothing happens, same thing here. We have defined something, but we didn't actually do anything else, right? So in mathematics, when we have a function, we can apply the function. That is, we use the function. But in programming, we say we call a function. So let's create a new line, past line 4. Sorry, past the ENDN. Yeah. And let's write f, opening parentheses, and any number, closing parentheses. Okay, let's run it. Oh, we got 5. How did we get 5?
Um, well, we line two, we have f parentheses x. Then we add a one to that x. Then we like declare four, so 4 plus 1 equals 5.
Yeah,
Yeah.
exactly. So in mathematics, we say we apply a function, we apply f and 4, but in programming, we say we're calling the function with 4. When we call a function, all line 5, like the 4, we call that the argument. These are what the parameters become, what the parameters take hold of. So when we call f with 4, the x in line 2 takes on 4. So whenever we have concrete values we're passing into the function, we call those arguments. So 4 is an argument. The placeholder for those values, we call that the parameter. So the parameter x takes on 4. So line 3, variable substitution happens. We get 4 plus 1, which gives us 5. All right. So notice how there are two windows in front of us.
Two windows, you mean on the left and on the right?
Exactly, yeah. You notice that. We have
Yeah.
been writing our program on the left, and whenever we run, we get an answer on the right. Let's actually click on the right window now. Let's stay on the right. I would like you to call the function again with a different number here and hit enter.
Like, do I copy paste this or
No, let's write it from fresh.
like the entire thing?
Oh no, just calling the function, just f and whatever. And a new number, 7. Perfect. Let's close it and hit enter. Ah, notice how we got an answer immediately. We didn't click run. Can we do that again? But can we do call f with an addition? So f opening parentheses and add two numbers in there. Cool. Okay, so let me do some explaining. So the right window allows us to sort of write one-line programs, and we can get back an answer really quickly. This is good for very fast feedback. In your own time, just some free time, feel free to play around with this. Notice how that f is defined on the left-hand side, but we can still access it on the right-hand side. Okay, so the left window, we call this the definitions window. This is where we define our program and any definitions. The right-hand side, we call this the REPL. That's REPL. R for read, it reads what you write. So when you write f of s7, it reads that. E for evaluate. To evaluate just means to get the answer of. So when we do f of 7, it evaluates to 8. Another way of understanding evaluate is it means to become a value, to turn into a value. That's why it's the word value in evaluate, where a value is its most simplified form. So 8 is a value because you can't simplify it any further. P
Yeah.
for print, once it has an answer, it prints it out. So f of 7, it computes 8 and prints it out, so we can see the 8. L for loop, loop because you can keep doing this again and again and again. So that's REPL. You don't have to know this. I'm just letting you know for your. If I say the word REPL, you know what I mean.
Yeah.
So this is good for fast feedback. This language is designed for beginners, and so this is a feature that this language has. Not all languages have this. Okay. Another observation I want you to make is that notice how we were able to get different values from f. Like we couldn't
Yeah.
redeclare the variable just now. Like when we say x is 2, we can't say x is 3, but we can pass in different values and get different answers. You see that?
Yeah.
Okay. So that's a property of function. And we didn't even change the function. We didn't even change our program, and we still got back new values. So that's the power of functions. If you remember num_min from just now,
Yeah.
num_min is a function. So it's just a function that they have defined for us, whereas f is a function that we have defined ourselves. Okay. So to summarize what we have done so far, we have explored
So is
arithmetic and
uh,
yeah.
so is anything a function then? Like if it takes an input and produces an output.
Yes, for our purposes, yes.
Okay.
Yeah. Uh okay. So to summarize, we have done arithmetic and algebra with numbers. In algebra, we saw that's variables, variable substitution, and now functions. We are basically exploring like mathematics, but with a computer. Okay. So this Zoom session is going to expire, so I'm going to send you a new link on Gmail, okay?
Okay.
All right, see you in a minute.
Zoomed in properly.
Oh, that's perfect. Yeah. All right. So we're going to shift gears a little bit. Can we delete f of 4? That's line 5. I want you to write the number 5. Okay, let's run it. Okay, we'll get back 5. Nothing special. You write 5, you get back 5. No surprises. Now, let me ask you, what does 5 mean?
Well, like it's just a number here. It doesn't mean anything because we've not like attached it to anything.
Okay, that's a very good answer, actually. Now, my next question is, how about 5 degrees Celsius?
I mean, isn't that the same thing?
Is 5 degrees Celsius the same thing as 5?
Well, do we need to like convert it or
So, like, if someone walks up to you and says, like, 5, is that the same thing as someone else walking up to you and say, oh, it's 5 degrees Celsius right now?
no, it's not the same thing.
It's not the same thing, right? What's the difference?
Well, there's like a way to measure temperature and
Yep.
it has different metrics, I think, or the way that it's calculated. So no, it's like miles and kilometers. Like 5 miles is not the same as five kilometers.
Yeah.
Yeah.
Okay, so it conveys it's context, right? The degree Celsius is providing context as to what the 5 means, right?
Yeah.
Okay. How about 5 kilograms?
It's also different.
Okay. It means weight now, right? Or
Yeah.
mass, how heavy, how light something is. Okay, cool. So they're all 5. But depending on whether I say 5 degrees Celsius or 5 kilograms, it means something a little bit different.
Yes.
So there are two worlds. There is the world of information, these ideas and facts about the real world, like 5 degrees Celsius. And there's the world of data. Data is what the computer sees. The computer sees 5, that 5 right in front of us. It does not know about temperature or weight. It only sees 5. This sounds philosophical, but it's a very practical idea because I claim our role as programmers is that we convert information to data, perform operations on data, and convert data back into information. Okay?
Yeah.
So, for example, let's say we have an electronic thermostat. The electronic thermostat has physical sensors that takes readings of its natural environment, like electrical resistance, movement of molecules in the air and whatnot. It has a bunch of numbers. So it takes the real world and captures it in numbers that it can work with. It's going to do arithmetic on those numbers, perform calculations of them to deduce a final number, and it's going to display that number. As a human being, we know that resulting number is the temperature, but the computer doesn't know that. The computer is just doing stuff with numbers, doesn't know it's dealing with temperature, right?
Yes.
So that's two worlds. That's the world of information, and this is where humans operate in, and that's the world of data. This is where the computers operate in. And as programmers, we facilitate the interaction between the two worlds. To reframe everything that we have done so far, all we have done is we have encoded information as numbers. So the word encoded means just to turn information to numbers. We've encoded information as numbers. Can we encode all information as numbers?
No, probably not.
Okay,
I
what do you
mean,
say? Why?
we need to convert it to data first. Like we need to translate it so a computer would understand.
Yeah. Okay, and let me give you a counterexample. Do you know how they say that computers are just a bunch of zeros and ones?
Yes.
And zeros and ones are numbers, right?
Yeah.
So everything can become numbers.
Well, yep. Well, probably, but depends on the size. Maybe some like if what if it, there's like a lot of data.
Even then, there's still zeros and ones, right?
Yeah.
Like right now, like around the world, there are massive, giant, massive, very rich corporations that are building giant data centers, which are essentially a bunch of zeros and ones, right?
Yes.
Yeah. So all information can be encoded as zeros and ones. This is what makes, the digital world possible. But do we want to? Do we want to encode all information as numbers?
Well, it depends on the task. Maybe.
Can you give me an example on a task where we don't want to encode information as numbers?
Well, what if there's like a street address with a name? Like, do
Hmm.
we convert that to a number?
You raise a very good point. Yeah. To add on to that, like right now, you and I, we're talking, we're conveying information to each other. However, are we speaking in numbers?
No.
No, right? Like, we're not speaking in Morse code. I'm not saying beeps and boops to you. We're speaking in a language. In fact, like during the World War, when communication technology wasn't as advanced, people had to communicate with Morse code. To do that, they had a room full of people decoding Morse code because any one person could make a mistake. You have to sit down and you gotta hear beep, 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 boop, boop, and you have to write the words on a piece of paper. That's incredibly slow. And so there's an
Yeah.
idea of efficiency and convenience. It's much more efficient and convenient to use words to communicate ideas to each other, right?
Yeah.
So we don't want to encode all information as numbers sometimes. And so that's what we're going to do now. We're going to find new ways of encoding information. Can we delete that 5? I would like you to write double quotes, hello, comma, space, world. All in the
Inside
double
the
quotes. Yeah. It's hello, comma, space, world. Okay, let's run this. Hello, world. We did not get back a number. We got back an entirely different species. This is a string. I think it's called that because it's like a string of characters. I'm not actually sure. Um, so yeah, we've unlocked a new way of encoding information. We also have strings. This hello world, this example is very historical. In the 1970s, there weren't like computer science was a very young field, and there were barely any programmers in the world. Like right now, everyone's a programmer, but back then, that's like a very rare thing. And there's this guy, a very established programmer. He wrote a book on how to program, and he used this example, hello, comma space world. Ever since that day, every book, lecture, video uses this example. This has become a rite of passage. To become a programmer, you must write this. So
so
congratulations,
am I a programmer now?
you're a programmer. This marks the point. So it's like 6:48 p.m. your time. You are now a programmer as of 6:48 p.m. Uh,
Hmm.
5th August 2026. It's a very
Awesome.
special day today. It's a very special milestone. You can do something later to celebrate.
Yeah, I'll buy a beer.
Yeah. Yeah. Um, yeah, so this is a very big thing. Hello world. And we can we can do stuff with, like just now we work with numbers and we can do arithmetic with numbers. Can we do arithmetic with strings? Can we add this string to another string?
I have no idea.
Let's try it. That's the only one way to find out.
Can I just copy this? Is that
Uh,
okay?
let's do a different string. Cool. Okay, let's run it. Let's see what happens. Hello world,
Nothing.
hi.
Oh
You see
yeah,
that?
yeah. I did not notice it. I
So it joined the two strings together. Okay. Um, could we change the plus to a minus?
should I try?
Yeah. Only one way to always try stuff. Oh, what happened here?
Where on the left side, hello world, the right side was to be given two numbers. So minus is meant for numbers, not for words.
Yes, it can only work. You can only subtract numbers, not strings. Well, I am making a distinction between words and strings. The reason why I do that is because a string can actually contain multiple words. For
So
example,
is
hell, yeah,
is a string anything that's within those brackets?
double quotes. Yeah,
Yeah, sorry, double quotes.
yeah, all good. You could also use single quotes actually. Either way works. Regardless, yeah, a string is anything between quotes. If you remove the quotes, what will happen?
It will stop being a string.
Yeah, it's gonna become a variable.
Oh,
Yeah, that's why the quotes are important. Okay. Anyway, so from this exercise, we can observe something. There is an arithmetic for strings. We can perform operations on strings the same way we can operate on numbers. However, as you can see with the subtraction, arithmetic for strings is fundamentally different from arithmetic on numbers, right? Huh. Let's delete line 5. I'd like you to write double quotes 5, like digit 5. closing double quotes, and let's run it. Nothing special. The same way we write hello world and get back hello world, we can write 5 and get back 5 in double quotes. On a new line, can you just write the number 5? No quotes. Here's 5. Let's run it. Okay. So I have a somewhat philosophical question again. Now that we have strings, and strings are a series of characters, and to write a number, you have to write a series of characters. Why do we need numbers? Why not make everything strings?
For different purposes, maybe. Like we use like the line 6 5 is a variable. We can use it for like mathematical stuff or functions. And this is we can use a string if we want to describe something, perhaps.
Yeah,
Yeah.
it's the ideal purpose, right? So while the same piece of information can be represented with multiple data types, there are strengths and weaknesses to each one. For example, we can't subtract two strings, but we can subtract two numbers, right? Oh, I should say, what is a data type? When I say data type, a string is a data type. A number is a data type. A data type is a classification of data. Okay. Okay. In 7 more minutes, I'm going to introduce one final idea, and then we'll call it. Let's delete everything, and we're going to introduce a third data type. So each data type that we've introduced so far encodes some information in some very fundamental sense. So numbers are used to encode like the field of mathematics. Uh, Strings are used to encode language. Language is very vital to civilization and communication. I'm now going to show you how to encode decisions. It can be said that life is a series of decisions, where a decision is fundamentally yes or no. For example, your decision to come to office hours, you must have said yes. Uh, so this idea of yes or no, on or off, right or wrong, true or false, these ideas of opposing dualities, in programming we call them boolean, and in programming they are true and false. Can you write true? That's true. And just run it. True. Great. Notice how we got back true. So true is a value in this programming language. Can you write false? That's false. Oh, yeah, can we delete the true?
Sorry.
Oh, okay, yeah, I should have mentioned that. So yeah, false. You get back false. Notice how the true and false are red in color as well. So these are the two values of booleans. So, when we work with numbers, there are many numbers. There's 1, 2, 3, 4, 5, and so on. For strings, there are many strings. You can say hello world, you can say hi, you can say bye. But for booleans, there are only two, true and false. No other. Uh, so the same way there's arithmetic for numbers and strings, there's arithmetic for booleans. Could you write false and true? That's false and true. Let's run it. Great. Go back false. Same thing. Can we change the and to R? That's OR. Let's run it. Go back true. So this and or, notice how they're bolded? We call them Boolean operators. They operate on Booleans. This is how we do arithmetic on Booleans. Okay, we're gonna close it off. I'm gonna share my screen. Should you stop sharing yours?
Did it stop?
Uh, I'm, yeah. So I'm pulling something up. Okay, share my screen. All right, let me know once you see it.
Yep.
Great. Okay, so here we have truth tables. So it looks daunting, but it's actually very simple. Each table is a Boolean operator. So you saw and or. There's actually
Is
one
that
more.
sorry, is that the table on the right?
Yes. Do you see it?
Yeah.
Yeah. So these are truth tables. So another way of understanding Booleans is that they encode truth, whether or not something is true. Each table is a Boolean operator. We have seen and or. There's also not. We haven't seen that. It does exist in a programming language. So in this table, 0 means false, 1 means true. Do you remember when I said that computers are just a bunch of zeros and ones?
Yes.
Well, these are the zeros and ones. You're looking at them. These things underneath the names, these are logic gates.
Sorry, zero means false and one is true.
Yes.
Okay.
Yeah. On top here, these are logic gates. Logic gates are like Boolean operators, but they are physical devices. So if one wire, so these are wires going to the logic gates. If one wire has electricity and the other wire doesn't, the resulting wire doesn't have any electricity coming out of it. Okay?
Yeah.
So computers are a bunch of zeros and ones, and our computers are made with thousands, millions, billions of these tiny things. These things are very tiny. Computers are made with billions of these things. And these things are what makes computation possible. Computers are a bunch of zeros and ones, and these logic gates stirs the zeros and ones, allowing for computation to happen. So each of these can be understood to be a function. They have input and output, where they take in booleans and produce a boolean. Um, so for n, we saw that true and false is false. For or, we saw that true or false is true. Uh, an intuitive way of explaining why that is that if I ask you, let's say you have a apple, and I ask, do you have an apple and a banana? You'll say, no, I only have an apple. So it's false. But let's say you have an apple, and I ask, do you have an apple or a banana? You say, yes, I have a banana. So for n,
See that and table. So is zero false, false, output is false. So it's like in math, like no, I think no, I'm sorry, I think I'm wrong. Sorry, it was just so
okay,
if I remember correctly, please correct me if I'm wrong. Like two pluses give two minuses give a plus. Like if you multiply, or am I wrong?
I know what
I'm
you're talking
thinking.
about. Uh, that only applies to XOR. Notice how
Okay,
XOR, if you give it the same thing, you always get back zero. But if the two things are different, you get back one. So the mathematical property you described only applies to XOR.
what does XOR stand for?
Exclusive OR. It's the same thing as OR, but the exclusive refers to the case where both are ones. If both are ones, it's still a zero.
Okay.
So like for example, if like my mom asks me, do you want ice cream or waffles? And I say I want both, my mom's going to tell me no, you can only have one of them. That's an
Hmm.
example of XOR, right? Okay. Um, as programmers, we only need to know about not and an or, unless you're really into like performance algorithms and you have to write really low level code, or you're an electrical engineer or cybersecurity researcher. Anyone that deals with really low level stuff, you don't need to know about the rest. You only need to know about not and an or. Okay?
So I should memorize that.
It's actually very easy. For n, if there's at least one zero, the result is false. If there's at least one true for or, the result is true. For not, it just flips it. Okay.
Okay.
We are out of time and I have another student. I'm gonna email you a bit of homework. If you have time, that's great. If not, that's okay too, and we'll pick it up the next time, all right?
Okay.
All
But
right, awesome.
can I ask you a question? How many of these sessions can I book per week? Is there a limit?
So at most once a day for now, and that might change.
Once a day.
At most once a day, yeah.
Okay. Okay.
Okay, I gotta run. All right, see you, Victor.
Thank you. Thank
No
you.
problem.
Bye.